All right. So today we're just doing vocabulary and symbols. So a lot of the stuff you've already known, or we talked about it already in this class so far. So here's standard forms of equations. I think this is very confusing. I think it's much easier to look at examples. I'm going to look at these examples instead. If we have an equation that just has a number in it, no x's at all, that is a constant equation. There's something called the degree, and the degree is the highest amount of variables of all the terms, the highest amount of variables. So how many terms do I have right here? There's one term. And because there's only one term, we would say this is a monomial. One term is a monomial. You've heard that before? Okay. And there's no x's at all, so the degree of this is 0. And because the degree of it is 0, we call it constant. So the degree right here determines the type, and over here the number of terms determines the name of what kind of like polynomial it is, okay? So these are two separate categories. So we look at the next example. I'm going to look at the example. F of x equals 5x minus 7. We've been graphing things like this, especially in chapter 1. 5x minus 7, when we graph it, what's it look like? Okay, we're going to have to participate today. What does it look like? It looks like a line, and that's because the x is to the first power. The degree, we look at all the different terms, which are separated by plus or minus signs. The degree would be the highest amount of variables in any of the terms. So there's one variable. So here's my degree, 1. Because the degree is 1, we call it linear, but you already know it's 1. How many terms are there? 2 terms. Binomial. So I have these like vocabulary words separated on different sides of the paper because they are totally not related to each other. I'm just reviewing vocabulary. Okay, if the degree is 2, it's quadratic. We just spent 2 chapters doing quadratics. So you might see a quadratic that looks like this, 2x squared plus x minus 9. The degree would be out of all of the terms, what's the highest amount of x's? 2. That's the degree. And that is quadratic because it makes a problem. There were 3 terms. What do we call 3 terms? Trinomial. My next example is x cubed minus x squared plus 3x. So how many terms do I have in this one? 3. Okay, there's 3 terms. And we already know 3 terms is a trinomial. Nothing new there. But what is the highest amount of variables in any of the terms? 3 is the highest amount because that's in the first term here. So that is its degree, the highest amount. And then if it's a degree of 3, we call it cubic. And then the last one we're going to talk about, this one has 3 terms, so this would also be trinomial. But what is the highest power in any of the terms? 4. So this has a degree of 4, and when it has a degree of 4, it's called quartic. So quadratic is 2, quartic is 4. Now there were not a whole lot of different examples of term-wise, so I'm just going to give you one more example for terms. So here's just an example for terms. How many terms does this have?
Oh, it's got 3. The highest is 3, right? But it's got 4. So it's 4. Wait, no, it's got 5. You're missing this.
Okay. Okay. So the 0 like we had to put in when we divided, doesn't really count for the number of terms because it's not really there. So how many terms does this have? 4 terms. But what is its highest exponent? What is its degree? 4. So what kind of quartic? See, it's in your chart if you forget what it's called. And then how many terms? It has 4 terms. So what do we call it if it has 4 terms? Just a polynomial. So wait, now I'm spelling it wrong, so I'm talking nomial. Poly means many. So polynomial just means that it has like more than 1 term. So really, all of these, except for the first one, are polynomials. It's just when there's 2 terms, there's a more specific special name. Just like all 4-sided figures are quadrilaterals, but the ones that have all 4 sides the same are called no. All 4 sides the same?
Oh. That's a circle.
That's a square, right? It's not.
No, it is not.
All 4 sides are the same.
If all 4 sides are the same, what's that
A
called?
rectangle.
Nope.
That's a square.
Nope.
Oh! I know what it is.
I'm giving you a geometry thing.
It's like it's like quadratic, like.
Nope.
No, I forget.
You all forget already?
Dude, that was last.
Wait. It says an R.
It's a round.
That is a square, my dude.
No, because what are my angles? How do you know that?
Both sides of it?
Are you allowed to assume?
No, because I guess that is kind of true because if you
No, because
could,
I could
you
have
couldn't have the things.
all 4 sides. I could have all 4 sides the same, but not angles. I just they look different.
Yeah, but no, you could like.
Right,
If it was a square, you
I
have to
know.
have the corner.
You have to have this part to make it a square. Yeah, that was like totally off on a tangent. We're not even talking about that right now. But you all forget. Yeah. Hey, guess what? That comes up again in math. All right. Oh yeah, chapter 9. Tangent. Okay. Now we're going to do really good polynomials, and we're going to decide, are these really polynomials? So the word polynomial is something that you need to know the definition of as well. And you have all this extra space up here. So we'll say if it's a polynomial, it's going to be written in the standard form, but things that people don't realize are x cannot be in the exponent in a denominator multiplied by another variable under a radical, a square root or a root of some sort. We'll put under a root because there's more than just square root. If it's a polynomial, x can't have any of this stuff. And then there's some things up here that you may not recognize unless I say like x. I'm going to say x must have, no, let me rephrase that. Must not have a negative exponent. If any of those things occur, then we cannot call it a polynomial. Now, if any of those things occur, we can totally do math with it. We can totally graph it. We're going to totally cover all that stuff. It's just, it won't be called a polynomial. So this is vocabulary and that's it. Okay? Just because I have an x that has a negative exponent does not mean I can't do stuff with it. We're just going to say, nope, that's not a polynomial. It's just a vocabulary word. Okay? So looking down here, we've got the very first example. We're going to see if this is in standard form, which is standard form, the x's go in descending powers, from top to bottom, from highest to lowest.
So it's true in this first one, yeah.
Yep, so standard form. It's already done, so we don't have to rewrite it. What is the degree? What is the highest exponent? So the degree is 3. The type, if the degree is 3, then it is called a
Triangle.
cubic. Why would it be called a trinomial? It has 3 terms, so then we'll call it a trinomial. So those are different things. They different names, like, the degree does not have anything to do with the number of terms and vice versa. And then the leading coefficient is the, when it's in standard form, the very first coefficient, the very first number that is on the term that has the degree. What is it? -2. Okay. It's easy stuff. So question B, is question B a polynomial by definition?
Absolutely not.
Okay, Austin, why not?
It is. Everyone else just said it was. So it's,
Well, I only heard 2 people talk.
It is.
You think it is?
I don't think so. Yeah, it's not.
Is it standard form?
It's not standard.
It's not in standard form, but I'm not going to bother to put it in standard form if it's not a polynomial.
It's not a polynomial. There's no
What?
point.
It doesn't have a what term? Or it doesn't have a what term. Okay, let's go back up to the top where we wrote, these are the rules. Does it follow all of those rules? And if not, what rules it
It
breaking?
cannot be under a root.
It's not under the root.
There's nothing a square root like that.
It is.
Is the x under the root? Okay, so the x cannot be under a root, but a number can be.
Oh, that's just 200? Alright.
Yeah, so you gotta look careful. This one is a polynomial. It is a polynomial. It does not break any of those rules, but it is not in standard form, as you already told me, so we're gonna rewrite it. So we have the square root of 2x to the 4th first, then minus 0.8x to the 3rd, and minus 12. So rearrange my terms so it goes in descending powers, that's standard form. From there we find our degree. What is the degree? 4 is the highest exponent of the terms, or not, it's not really the highest exponent, it's how many variables are in the most variables in a term. Struggling. Type.
It is a
Quartic, and then half, oh, that's spelling
It
wrong.
is a quartic.
Quartic, and how many terms?
Trinomial.
Trinomial. Quartic trinomial. And the leading coefficient is,
Oh, it's there's square root.
it's just the number square root 2. Okay, number C. Not a number. Letter C.
It's not. It's only negative.
Not a polynomial? But what do you mean because it has a negative? Because there's a negative in front?
No, because the 7x is a negative value.
Because
It's a negative 1.
negative exponent. Thank you. So then we don't have to answer any other questions because it's not a polynomial, it does not have degree, it does not have leading coefficient, all that fun stuff. How about D? Not a polynomial? Because x is the exponent. And it can't be. So not a polynomial because x is the exponent. Okay, when you get done writing that, turn the page to student practice. I just want you to find what is not a polynomial and write down why it is not. Find out of those 3 what's not a polynomial and write down what is not. y. Oh, polynomial. Decoding.
Yeah, I'll be able to. I'm ready for more.
Well, we're halfway done.
Oh, let's start dancing now. I thought we were supposed to dance today.
Which one is not a polynomial? Number 2, why not? Okay, example 2 we're not going to do because you should already know how to do that from previous course. Evaluate that when x is 3. What do you do? Okay. Or you could do synthetic division now that we learned that. So 2. And then there's 2 more practices. Now we're going to do what's called end behavior, and this is where we dance. I'm going to pause the video because you can't see what I'm doing, so. Okay, we look at this right here. We're going to determine from our first term if the degree is even or odd, and if the leading coefficient is positive or negative. Now, you should also make sure that is the correct leading term, like that's the correct first term, because occasionally they might be in the wrong order. Is this in the right order? Or we can do it before? Okay, so the first term, negative 0.5 x to the 4th. Is the degree even or odd? And is the leading coefficient positive or negative? So then what you do is you go like this and you say, what would my arms be doing right now? My arms would be like this. Okay, there's my arm. I have no idea what's going on in the center, but that's my arms. So now we're going to write the answer to this, but I have to show you how to write the answer, and that comes from the other paper. So this is the symbols you're going to learn today. Okay, you know we do left to right, so I'm going to look at the left side of this graph first. So this is an example here of a degree that is odd, and the leading coefficient is positive. That's not the one that we're doing right now on the next page, but this is just an example. Degree odd, leading coefficient positive, that's kind of maybe what it would look like. The most important part, the part that's not dashed, are those arrows. And under here, these are symbols. I will tell you that it will always have the same symbols for the left and right. And once you know what these symbols mean, it's really easy to set it up. So the arrow itself, the arrow is not pointing in a direction. It's a symbol that means a word. It means approaches. Or goes to, or goes towards. That is a word. You notice that every single arrow in all of these 4 boxes, all of them face the same direction. Because they're not telling you a direction. It just means the word approaches. So you just have to decipher that word. So the other thing that you'll notice is that every single box up here, the last part of it is the same for every single scenario. I just underlined all of them, but you can't see them all. The last part of it is the same for every single scenario. The left scenario always says as x, and what's the arrow mean? Approaches negative infinity. The right side always says as x approaches positive infinity. It always says that in every single scenario. Because every single one of them has to do with x going left and x going right. Remember, x goes left and right? If x is going to the left, which infinity is it pointing to? Negative infinity. So that's saying as x approaches negative infinity, that's saying the left. That's what this means right here, the left. Over here, where it says as x approaches positive infinity, that right there means the right. So what's happening right above it, f of x, what does that stand for? Y. What did you say? The answer is the output when you put in x and you get out the value of that function, which we normally call y. So this is the y values. And that is saying, if you look at everything combined, this is saying on the left side, which is when x goes to negative infinity, what are my y values doing? So you look at the graph. Remember, y's are up or down. Can you tell me, looking at this graph, what my y's are doing on the left side? Which infinity is that?
Negative.
See how it says f of x, the y value, approaches negative infinity. And then it says as x is going to negative infinity, because that's saying to the left. Over here, which direction is y going?
Positive.
Up, which is towards positive infinity. So it says the y values, the f of x, approaches positive infinity as x approaches positive infinity, because that's saying to the right. The only thing that you could change about these symbols every single time is where the y's are going. Like on this next one here, the x's, this is still left, and this is still right. But now my y values are going to different places. Like over here, my y values on the left side are going positive, and on the right side are going negative. So you have this if you are forgetting things, but you will have to remember this on your own eventually. So let's go back to our example that we started. You already know what it should look like. We just have to put it into symbols. So let's think about the left side first. Think about the left side first. And you saw on the other side, it always starts with f of x approaches. So you look on the left. Where is the y's? What's the f of x? What's the function doing? Up or down? So down means negative infinity. And then you always write as x approaches, and then to the left, which way is x going? To the left is which infinity?
Positive.
Left
Oh, yeah.
is negative. So down is negative, left is negative. So now on the right side, we start out with f of x approaches. What's it doing on the right side? Up or down? Down is which infinity? Don't think about it. Don't overthink about it. Like down is which infinity? Negative. And then as x goes to, now this is the right, which is the right, which infinity is the right?
Positive.
Positive infinity. The only part of this that changes when you do different questions is the part that I put in the yellow or orange boxes. Everything else is always the same exactly, every single time, except for what's in there. So let's look at number 6. Describe the end behavior. Is this in standard form before we start? Okay, so then we're looking at this term. And we need the degree, and we need the leading coefficient. But we don't actually care about the numbers. We just need to know even or odd, positive or negative. Degree, even or odd? Odd. Leading coefficient, positive or negative? Sketch a graph. Odd, positive. They go different directions, and they go uphill from left to right the way we read. So I'm going to start with the left. So everything I wrote there is the same. F of x approaches something as the x goes to negative infinity. That's saying, as we go to the left, what's the graph doing? Now you look at your picture and say, on the left side, is it going up or down? Down is negative infinity. So then we do the right side. So the right is when x goes to positive infinity. So over here, is my graph going up or down to the right?
Positive.
Positive infinity.
That's hard to do.
Yep. Ready? Okay, so your assignment is this worksheet, and you're going to do number 1 immediately. Don't sit here and piddle around, because I'm going to walk around and check everybody's number 1.